Hello, welcome to my mathematics YouTube channel. I'm thrilled to be here and excited to share my passion for all things and mathematics with you. So, mathematics is a fascinating subject that has a power to explain the world around us, right? So, it is a language of science, engineering, and technology, and it plays a critical role in shaping our everyday lives. So, whether you are a student, a professional, or simply someone who enjoys learning mathematics has something to offer for everyone, right? So, through this channel, I hope to inspire and educate you about the wonderful world of mathematics. So, my goal is to make math fun, approachable, and accessible for all. So, from algebra to calculus, geometry to statistics, I'll cover a wide range of topics and provide clear explanations, helpful tips, and engaging examples. So, whether you are looking to ace your maths class, prepare for a standardized test, or simply broaden your knowledge, this channel is for you. So, I invite you to join me on this mathematical journey and explore the beauty or the powers of numbers. So, thank you for watching and let's get started. So, our today's topic is quadratic equation. So, first of all, today we are going to discuss the condition for common roots. Okay, condition for common roots. So let us have two equations. One is ax square plus bx plus c equals to 0. Another one is dx square plus ex plus f equals to 0. Now let us have, like, let alpha be a common root for these two equations. So if alpha be a common root for these two equations, we'll have a alpha square plus b alpha plus c equals to 0, and d alpha square plus e alpha plus f equals to 0. Now we are going to solve for alpha using cross multiplication process. So here the variable is alpha square, we'll take that one. Next, the variable is alpha, we'll take that one. And the constant part, we'll take that one. Okay. So for alpha square, what we are getting? B into f minus c into e, right? For alpha, what we are getting? C into d minus a into f. And for the constant part, what we are getting? A into e minus b into d. Okay. So from here, we are going to find the values of alpha square and alpha. So first, let us find the value of alpha square. So if I take this part here, so we'll get the value of alpha square. So alpha square will be equals to bf minus c by ae minus bd. Now the value of alpha, it would be again cd minus f by ae minus bd. Okay. Now we have the value of alpha square, we have the value of alpha. Now at some point we are going to equate them. How we can equate them? We can equate the value of alpha square. So that means we are going to square the second equation, and after that one we will equate it to the first one, first value. So if we square the second and equate to the first, we'll get cd minus f by ae minus bd whole square, that is equals to bf minus c by ae minus bd, right? Now we are going to simplify it. So if we simplify it, what do we get? cd minus af whole square, that is equals to bf minus c into ae minus bd. So this is the condition for common roots for two equations, right? Now this is the condition for common root for like one common root for two equations. Like, do not mistake it for two common roots, because for two common roots what will happen? The coefficient of the corresponding, say, coefficient of x square, coefficient of x, and the like constant terms, the ratio of these coefficients, that would be equals to equal. I mean to say a by d that would be equals to B by E, that would be equals to C by F. Now, if the ratio of these particular terms are equal, that means we can say these two equations actually the same equation. That's why both the roots are same, right? So, for two common roots, always that those two equations will be the same equation for two common roots. Okay. Now, let us have one example on this. Let us have one equation like if x square plus cx plus ab equals to 0 and x square plus bx plus ca equals to 0. So let these two equations have a common root. Okay. Now what we have to do, we have to show that the other roots for these two equations, the other roots will satisfy the equation x square plus ax plus bc equals to 0. That means, see, for the first equation we have one root alpha, another one is beta. Okay. And for the second equation we have one root alpha, another one is gamma. That means we are going to form the equation whose roots are beta and gamma, right? So let's form it. So first of all, these two equations have a common root. Say alpha is a common root, right? So if alpha is the common root, then the value of alpha will satisfy these two equations. That means we'll get alpha square plus c alpha plus ab equals to 0. Another one will be equals to alpha square plus b alpha plus ca equals to 0. So from here again we are going to solve for alpha square and alpha. So if we want to solve for alpha square and alpha, what we get? So first of all, alpha square, then we have alpha, then we have the constant term. So for alpha square, what we are getting? C into ca, that means c square a, minus ab into b, that means ab square. For alpha, what we are getting? ab minus ca. For the constant term, what we are getting? b minus c. So now from this one, if I want to find out the value of alpha square, uh, let us find the value of alpha. So value of alpha, it would be like, I'll take this part here. So I'll get, if I take a common, b minus c, a into b minus c in the numerator, and b minus c is already there in the denominator. So this b minus c get cancelled. I get the value of alpha equals to a. Again, another thing we can do, that is alpha square by alpha, that is equals to minus a. If I take common from the numerator, it will be b square minus c square by, if I take a common, b minus c. So a get cancelled. If I cancel b minus c from there, like b square minus c square, it will get factorized b plus c, b minus c. If I cancel b minus c, I'll get minus of b plus c, right? And here this alpha square alpha, if I cancel it, I'll get the value of alpha. So previously we already knew the value of alpha I got, that is equals to a. So a equals to minus of b plus c. So that means a plus b plus c equals to 0. This is what we are getting. Now the value of alpha equals to a. This is what we already received, right? Already we found out the value of alpha equals to a. For the first equation, x square plus cx plus ab equals to 0. X square plus cx plus ab equals to 0. If two roots are alpha and beta, so the product of two roots, that means alpha beta, would be equal to c by a. So here it would be ab. The value of alpha you already got, that is equals to a. So a into beta equals to a into b. So a get cancelled, we get the value of beta equals to b, right? Now again for the next equation, the next equation was x square plus bx plus ca, right? X square plus bx plus ca equals to 0. Let the two roots be alpha and gamma. So that means product of the two roots alpha into gamma, that is equals to ca. So the value of alpha is already a. So a into gamma, that is equals to ca. So a get cancelled. So you get the value of gamma is equals to c. Now we are going to form one equation with this particular roots, beta and gamma. So the equation will be x square minus beta plus gamma into x plus beta gamma, that is equals to 0, right? That would be our equation. So here x square minus the value of beta is equals to b, value of gamma is equals to c, minus b plus c into x plus beta gamma, that means b into c, equals to 0, right? So this is what we are getting. Now b plus c, we already found that a plus b plus c equals to 0. That means the value of b plus c equals to minus a. So we'll put the value of b plus c here. X squared minus of minus a, that means plus ax plus bc equals to 0, and hence proved that the other roots is satisfying this particular equation, x square plus ax plus bc equals to 0. Okay, now the next one. The next topic is expressions reducible to quadratic form. Like there are so many equations which seems like they are not in quadratic, but we can reduce those particular equations into quadratic, and then after that one we can solve them, right? So let's see how we can do it. Let's explain it with one example. Say we have one, like we have to solve for x for this particular equation, 4 to the power x minus 3 into 2 to the power x plus 2 greater than 0. So naturally you can see from this equation the domain for this particular expression is minus infinity to plus infinity, right? The domain for this expression, x can take any value, minus infinity to plus infinity. Now if I take like from here 4 to the power x, it can be expressed as 2 to the power x whole square, right? So that means it can be transferred to a quadratic equation of 2 to the power x. So if I take 2 to the power x equals to t, so this particular equation will be transferred to the form t square minus 3t plus 2 greater than 0, right? Now if I factorize this part, what do I get? T minus 1, t minus 2, that is greater than 0 actually. So t minus 1, t minus 2 greater than 0. So what is the interval of t, or where t lies? That is what we have to find out. So let's see where t actually lies. So if I put t minus 1, t minus 2 equal to 0, I'll get the values 1 and 2. Right. So first of all, I'll point it out 1, 2. So if the value of t is greater than 2, if I take any value which is greater than 2, so what do we get? Say it is 3. So 3 minus 1 positive, 3 minus 2 positive. So yes, it is positive. So it is satisfying that particular inequality. So the value of t can be greater than 2. If I take any value of t which is less than 1, that means say I'm taking 0. So if I take t equals to 0, 0 minus 1 minus 1, 0 minus 2 minus 2, minus into minus it becomes plus, so it is also satisfying the inequality, right? Now if I take any value which lies between 1 and 2, say it is 1.5, 1.5 minus 1 positive, 1.5 minus 2 negative, positive, negative, negative, right? So it is not satisfying the inequality. So the value of t, from here I can say it is satisfying that t belongs to minus infinity to 1 union 2 to plus infinity, right? T belongs to this particular region. So from here what I can say, that t is less than minus infinity to 1 and 1 to 2 plus infinity, right? So from here t is less than 1, and also the value of t is greater than 2. From the left inequality left interval, we can say t, the value of t when it is lies between minus infinity to 1, that means t is less than 1. From the right interval, t lies between 2 to infinity, that means the value of t is always greater than 2. This is what we are getting, right? Now what is t? T is actually equals to 2 to the power x, right? So that means we can say 2 to the power x is less than, for 1 I can use 0, union 2 to the power x, again it is greater than 2 to the power 1, right? This is what we can say. So it can be implied as, because 2 is greater than 0, 2 is a positive number, we can say x belongs to minus infinity to 0, union 1 to plus infinity, right? Yes, the value of x is always greater than 1, so 1 to plus infinity, and this is our solution. Okay, so we what we actually have done, we have reduced that particular inequality in a quadratic equation. Then after that one, we have done factorization, and we check the intervals. That's it. This is what we actually have done, right? Now again, there are some situations in quadratic where we can face some sums involving logarithmic functions. Now what is that? We already know, like if a to the power x equals to m, then x is equals to log m base a. Here the value of m and a, it is greater than 0, and a cannot be equals to 1, right? So this is the main condition of logarithm. Now along with that one, we have, if log a base x, it is greater than log a base y, so it will imply x is greater than y. Okay, now how we are going to use it? How we are going to use it? Say we have a problem. We have a problem like this: log of 2x plus 3 in the base, and here we have 6x square plus 23x plus 21, that is equals to 4 minus log of 3x plus 7, and here we have 4x square plus 12x plus 9. Okay, and we have to solve for x. Okay, so the given equation, if I factorize this part, it's like 6x square plus 23x plus 21, and this 4x square plus 12x plus 9. So the given equation can be written as log of 2x plus 3 is in the base, and here we have 2x plus 3 into 3x plus 7. 2x plus 3 into 3x plus 7. For the next part, we have 4 minus log of 3x plus 7 in the base. Here we have 2x plus 3 whole square. Let us make it as 1. Okay, so now the equation 1 is defined. So when a log is defined, already I have said the log is defined when the value of m and a, they are greater than 0 and a not equal to 1. So these are the particular situations where the log is defined, right? So we have to, like when I'm saying the equation 1 is defined, that means the log is defined there. So we have to check in which particular intervals this m, the values of m and a, they are greater than 0, and where m a not equals to 1. So let us check that one. Okay, okay, so here for the first part, this 2x plus 3 into 3x plus 7, 2x plus 3 into 3x plus 7, that should be greater than 0. Okay, so that means where does x lie? We have to check that one, right? So if I draw a number line, if I make it 0, like 2x plus 3 equal to 0, that means x will be equals to minus 3 by 2. And again 3x plus 7 equals to 0, I'll get x equals to minus 7 by 3. Okay, so in this, but as because they are greater than 0, what will happen, like we have already seen, so x will be less than minus 7 by 3, or it can be more than minus 3 by 2, right? So that means from here what we can see, the value of x, it belongs to this particular interval minus infinity to minus 7 by 3 union minus 3 by 2 to plus infinity. Okay, so here x can belong. Next part is, it's not only that the value of a will be greater than 0, the value of a will also be greater than 0, and a is not equals to 1. So that means 2x plus 3, this is greater than 0, and it is giving us x is greater than minus 3 by 2, right? So the value of x, from here I can say x belongs to minus 3 by 2 infinity. And also we know this 2x plus 3 cannot be equals to 1, right? So cannot be equals to 1, that means minus 2. So x cannot be equals to minus 1. X cannot be equals to minus 1. So if I, along with that one, from the next part, what do we get? That 2x plus 3 greater whole square, that is already greater than 0, it's fine. 3x plus 7, that should be greater than 0. 3x plus 7, it is greater than 0. So that means x is greater than minus 7 by 3, right? Minus 7 by 3. So it is giving me x belongs to minus 7 by 3 plus infinity. Along with that one, this 3x plus 7, it cannot be equals to 1. So that means my 1 minus 7 minus 6. So x cannot be equals to minus 2. Now we are going to find the common region of this particular inequalities. So to find the common region for this particular inequalities, we are going to draw the number line. Okay, so this is our number line. Here usually we have few points. The points are minus 0, minus 1, then minus 3 by 2, then minus 2, then minus 7 by 3. So these are the points we have here, right? Okay, now we are going to plot this particular region. Like the first one was x is in between minus infinity to minus 7 by 3 and minus 3 by 2 to plus infinity. Now if I plot it, what do I get? Minus infinity to minus 7 by 3 and minus 3 by 2 to plus infinity, right? The next part, it is saying x is x is minus 3 belongs to minus 3 by 2 to plus infinity. Okay, great. Minus 3 by 2 to plus infinity, that means again this part. And along with that one, it is saying x cannot be equals to minus 1. So this particular point, we cross it. X cannot be equals to minus 1. The next part is x is greater than minus 7 by 3 and x cannot be equals to minus 2, right? So greater than minus 7 by 3, x cannot be equals to minus 2. Now if I combine, so what is the common portion of these three inequalities? The common portion is this one. X is greater than equals to minus 3 by 2 and x not equals to 1. So what is the interval of x? X belongs to minus 3 by 2 to plus infinity, but x cannot be equals to minus 1. So x cannot be equals to minus 1. So this is giving me the domain for that expression, right? So what it is giving me? The domain of the expression. So once I get the domain, now I'm going to solve the expression. So again, I'll get back to equation number 1 and I'll simplify it. This is our equation number 1. So I'm going to simplify it. So let's see what I'll get after simplifying this equation number 1. So if I start simplifying it, what do I get? Log of 2x plus 3 in the base. So here I am having 2x plus 3 plus log of 2x plus 3 in the base. Here I am having 3x plus 7 equals to 4 minus twice of log of 3x plus 7 in the base, and here I have 2x plus 3. So from here the first term, like log of 2x plus 3 base 2x plus 3, it will give me 1, right? For the next term, like log of 3x plus 7 in the base 2x plus 3, if I take it as t, so when I'm having log of 2x plus 3 base 3x plus 7, it will give me 1 by t. So let us take this log of 3x plus 7 base 2x plus 3 equals to t. So if I take this one equals to t, that means I'll get 1 plus t equals to 4 minus 2 by t, right? Now I'm going to simplify it. If I simplify it, I'll multiply it by t, I'll get t square plus t, that is equals to 4t minus 2. So t square minus 3t plus 2 equals to 0. So if I factorize this part, I'll get t minus 1, t minus 2 equals to 0. So from here I'll get two values of t. One is t equals to 1, another one is t equals to 2. Now if t equals to 1, so as we are getting two values of t. If t is equals to 1, so that means log of what we have taken, t is equal to 3x plus 7 log base 2x plus 3, right? So log of 3x plus 7 base 2x plus 3, that is equals to 1, right? So that means it's going to give me this 3x plus 7, it is equals to 2x plus 3 to the power 1. So that means 2x plus 3 itself. So 2x plus 3 itself, from there I'm getting x is equals to minus 4, right? Now if t equals to 2, so that means log of 3x plus 7 by 2x plus 3 equals to 2. So it is giving me 3x plus 7 equals to 2x plus 3 whole square, right? So if I simplify it, I'll get 3x plus 7 equals to 4x square plus x plus 12x plus 9. So that means 4x square plus 9x plus 2 equals to 0, right? So I'm going to solve it, like factorize it. 4x square plus 8x plus x plus 2 equals to 0. So 4x common, x plus 2 plus x plus 2 equals to 0. So that means 4x plus 1, and here I am having x plus 2 equals to 0. So it will give me x equals to minus 2 and minus 1 by 4. So we are having three values of x, right? X equals to minus 4, another one is x equals to minus 2, another one is x equals to minus 1 by 4. Now the thing is that what was our domain? Our domain was this one. That means x belongs to minus 3 by 2 to infinity. That means x, the value of x is greater than minus 1.5, right? Practically speaking, like frankly speaking, it is minus 1 greater than minus 1.5, and x cannot be equals to minus 1. So this is the domain of the function. So as the value of x is greater than minus 1.5, so it cannot be equals to 4, or it cannot be equals to minus 2. So only one possibility is there, that x will be equals to minus 1 by 4. So our solution is equals to x equals to minus 1 by 4, and hence our answer. Simple, right? Yeah. Now you're coming another topic, that is called the modulus of the function. So modulus. See, modulus in this particular topic, it is saying let there be a function like mod of fx we want to find out. Mod of fx will give me fx when for all x fx is greater than 0. It will give me fx. It will be equals to minus of fx when for all x fx is less than 0. I'm going to say mod of minus 5, it will give me 5. Like when the value within the mod is negative, we'll give another negative sign to make it positive, right? This is the basic thing of modulus function. Now we are going to solve one equation using this modulus function. Say mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3 greater than equal to 6. See, from this problem, first of all, in the particular expression, we can find three values of x, right? Like if I put x minus 1 equal to 0, it will give me x equal to 1. If I put x minus 2 equal to 0, it will give me x equal to 2. If I put x minus 3 equal to 0, it will give me x equal to 3, right? Now in the number line, if I put these three values, say this is my number line. So x equals to 1, 2, 3. Now, from this particular number line, I'm going to find the number of intervals. See, the number x can be less than 1. So this will give me one interval. X can lie within 1 and 2. Next interval. X can lie within 2 and 3. Another interval. And x can be greater than 3. So how many intervals we are getting? The value of x can be less than 1, one interval. The value of x can be between 1 and 2, second interval. The value of x can be between 2 and 3, third interval. The value of x can be greater than 3, fourth interval. So we have to consider all these four cases. Okay. So first one, case 1. So in case 1, x is less than 1. Okay. So if x is less than 1, from our inequality what we can see, the value of x is less than 1, that means x minus 1, it will give me a negative value. That means I have to give a negative sign to make it positive. Say x is less than 1 means x is equals to 0. So 0 minus 1, it become minus 1. So I'm getting a negative value within the mod. So I have to give another minus sign to make it positive. So when the value of x is less than 1, x minus 1 is giving me a negative value. So I'll take it out as minus of x minus 1, and it is true for x minus 2, it is true for x minus 3. Every time when the value of x is less than 1, x minus 2 will be negative, x minus 3 will be negative. So in each case, for every one, we are going to give one negative sign. So I'm giving one negative sign for everyone. Now I'm going to solve it. So we are getting minus 3x plus 1 plus 2 plus 3, that means plus 6 greater than equal to 6. So it's giving me minus 3x is greater than equal to 0. That means x is less than equals to 0, right? X is less than equals to 0, that means the solution set for this particular case, it is actually x lies between minus infinity to 0, 0 inclusive, right? Okay. Now the next case. The next case, which interval will take? Will take x is greater than equal to 1 and x is less than 2. Okay. So case 2 is x is greater than equals to 1 and x is less than 2. So if it happens x greater than equals to 1, x less than 2. So in that case, the first part of our inequality, mod of x minus 1, when the value of x is greater than equal to 1, that means mod of x minus 1, it is giving me a positive value. Value of x is greater than equal to 1. Let us take it as 1.5. So 1.5 minus 1, it is giving a positive value. So I'll take it as positive. I'm not going to multiply it with a negative sign. So I'll take it out x minus 1 from there. But as because the value is less than 2, mod of x minus 2 or x minus 2 will be a negative value. So mod of x minus 2, for that one I have to multiply it with a negative sign. So it will become minus of x minus 2. For the third part again, mod of x minus 3, I have to multiply with the negative sign. Because mod of x minus 3, it will give me a negative value. X is less than 2. Naturally, it will give me a negative value. So now this part is greater than equal to 6 again. So as this part is greater than equal to 6, what do we get? X minus x, x get cancelled, so only one x is left. So here we have 2 plus 3, 5 minus 1. So that means 4 greater than equals to 6. So minus x greater than equals to 2. So that means x is less than equals to minus 2. This is what we are getting, right? but x is less than equals to minus 2. But see here, for the inequality, what is the portion we have taken? Like the defined portion is x lies between 1 and 2. And after solving the inequality, we are getting x is less than equals to minus 2. So is there any common portion? So let us check whether there be any common portion or not. So the points are 1, 2, 0, minus 1, minus 2. Anyway, so from the inequality where we started with x lies between 1 and 2. So it's like this, x lies between 1 and 2. Now after solving the inequality, we are getting x is less than minus 2, that means this portion. Do they have any common points? No, they don't have any common points, right? So as they don't have any common points, the solution set for this particular part, it would be S2 will be equals to null set, as they don't have any common point. So our next interval which we are going to check is x is greater than equal to 3, that means this one, x greater than equal to 3 and x less than greater than equal to 2 and less than 3, right? So our next case 3, x greater than equals to 2 and less than 3. Again, when x is greater than equal to 2, mod of x minus 1, it will be positive. There is no such problem. Mod of x minus 2, it will again positive. There is no problem. But mod of x minus 3, it will be negative, as because the value of x is less than 3. So x minus 3 will be negative, right? So it will be negative. Sum of these 3 is greater than equals to 6. So 1x get cancelled, so we'll get 1x. So here we have minus 1 minus 2 minus 3 plus 3. So value of x is greater than equal to 6. Directly we are getting. So again, as we are getting that value of x is greater than equal to 6, now we are going to check, like here we have one value of x which lies between 2 to 3. Here we have x is greater than equal to 6. So is there any common point? So let us check using the number line. So here we have 2, 3, dot dot dot, then 6. So from the inequality for our case, we have taken the value of x lies between 2 to 3, and after that one we get the value of x lies, like value of x will be greater than equal to 6. Do they have any common point? No, they don't have any common point, right? So as because these two intervals don't have any common points, so the solution set for this one will be equals to a null set. There is no solution, right? As because there is no common point. Now case 4, our last case. Case 4 is when the value of x, it is greater than equals to 3. That would be our last case, right? So here the value of x is greater than equals to 3. So for that one, mod of x minus 1, it is positive. The value of x is more than 3. So x minus 1 is positive. Along with that one, x minus 2, that will also be positive. Along with that one, x minus 3, that will also be positive. And sum of them is greater than equal to 6, right? So what we are getting from here? So 3x minus 6 greater than equal to 6. So that means 3x is greater than equals to 12, or x is greater than equals to 4. Now we have to check whether x greater than equals to 3 and x greater than equal to 2, do they have any common point or not? Let's see. So this is 3, this is 4, and this time I'm going to use green color. So x greater than equal to 3, so it's giving me this particular portion, okay? And x greater than equal to 4, I'm going to use this particular portion, yeah, this one. Do they have any common point? Yes, of course they have common points. This particular region, like x is greater than equals to 4 to infinity, it is giving me the common portion for these two inequalities, right? So we can say for this particular solution set is 4. Here the solution set is 4 inclusive, as because greater than equal to 4 is there, and plus infinity. Now see the solution sets which we already received, S1 equals to this one minus infinity to 0, S2, S3 null set, and S4 is 4 to infinity. So if we add all these solution sets, what would be the solution set for S? So the solution set for S is equals to minus infinity to 0, 0 inclusive. Mind that this is very important thing. Like when you are giving some interval, you have to check whether it is equal to or greater than 0 or not. If it is greater than equal to 0, you have to include 0. Okay. Union 4 to infinity. Here also 4 is inclusive, and this will give us a solution for the value of x. Okay, so when there be a modulus function, we can easily solve it by using this particular interval, right? Only by using the concept that in which interval x will be positive, in which interval the function will be negative. Now I'm going to give you one homework for this modulus function. The homework is mod of, like, 2 to the power mod x plus 2 minus mod of 2 to the power x plus 1 minus 1 equals to 2 to the power x plus 1 plus 1. So here again one hint I can tell you, like you just have to check, like if mod of x plus 2 is there, so one interval you are getting that x plus 2 is greater than 0, less than 0, like if the value of x is greater than minus 2. So in the same way you have to find the interval for this particular portion, and then after that one you have to make cases and you have to check where the function is giving you the positive or negative value. Okay, and accordingly you have to find the value of x, right? This is it, simple. Okay, so this is it for today. Again, I'm going to, like, I'll come with some more videos with some more problems on mathematics or quadratic equation. Like right now I thought like I'll continue with quadratic equation. So even I have something like I thought like even integrations I'll introduce. Okay, so yeah, let's see, like I'll come with the next video with some more problems on quadratic equation. Okay, till then, bye, ta.